Hi everyone! In this video we're going to learn how to find trigonometric function values for angles expressed in radian measure. Overall, this process is very similar to when we have to find trigonometric function values of angles expressed in degrees. But let's look at a few specific examples. In the first example, we need to find sine of 4 pi over 3. And I have the unit circle here to help me to answer that question. As you know, points on the unit circle represent sine and cosine of the corresponding angles. Now, angle 4 pi over 3 is labeled on this unit circle, and it's right here. So this means that sine and cosine of this angle are represented by these coordinates. Well, we're interested to find sine, and we know that sine corresponds to the y-coordinate of the point. And that means that sine of 4 pi over 3 equals negative square root of 3 over 2. So this is how quickly we can determine answer in this case. Let's try another example. For the second example, we need to find tangent of 11 pi over 6. And again, 11 pi over 6 is the angle that's labeled on this unit circle. But this time I need to do some additional steps to find tangent, because tangent itself is not shown on this unit circle. Well, and there are two options of how I can find the value. I'm going to show you both of them, and you're going to choose which one you find easier. For the first method, we need to recall that tangent of an angle is defined by y over x, where y and x are the coordinates of the point that sits on the terminal side of that angle. Well, that information we know. These are the points on the terminal side of the angle that measures 11 pi over 6. So that means that to find tangent of 11 pi over 6, we simply have to take the y-coordinate, which is negative 1 over 2, and divide by the x-coordinate, which is radical 3 over 2. So as you can see, method 1 involves some computations. So to divide these two fractions, I have to take negative 1 over 2 and multiply by the reciprocal of the denominator, 2 over radical 3. As I divide out 2's, and I'm going to get negative 1 over radical 3. Since there's a radical in the denominator, the fraction has to be rationalized, so I'm going to multiply by radical 3 on the bottom and on the top. And that gives me negative radical 3 over 3. So that's going to be the answer. What is method 2? For method 2, we're going to use the reference angle, because I know that tangent of the reference angle will have exactly the same numerical part as tangent of my angle. How do we find reference angles for angles expressed in radian measures? Well, it's actually very easy, because we already talked about how all related angles are going to have same number in the denominator. So that means that if our angle is 11 pi over 6, that means that its reference angle is going to be pi over 6. So theta prime equals pi over 6. So the denominator is the same as the denominator of the given angle. And of course, all fractions have to be in the simplest form. Next, what is tangent of theta prime, of the reference angle? In other words, what is tangent of pi over 6? Well, answer to this question I can easily find in the table of trigonometric function values. Here's tangent, here's pi over 6. That means the tangent of pi over 6 is radical 3 over 3. Radical 3 over 3. Okay, we're almost there, because now I'm going to say that tangent of my angle, 11 pi over 6, has exactly the same numerical part, radical 3 over 3, and the only thing that I have to check at the end, whether it's going to be positive or a negative value. So I'm going to go back to the unit circle and remind myself that 11 pi over 6 terminates in the fourth quadrant, and in the fourth quadrant, tangent is negative. Negative radical 3 over 3, house of the fourth quadrant, Q4. And that's how I obtain the answer using the reference angle. And of course, the answers are the same no matter what method you use. Let's try another example. This time we need to find cosine of 11 pi over 4. And as I look around this unit circle, I see that 11 pi over 4 actually is not labeled on this here. In fact, the last value with denominator 4 is 7 pi over 4. Well, that means that this angle rotates more than one full revolution, so it's more than 2 pi. Well, we still need to determine where it terminates. So I'm going to take 11 pi over 4, and I'm going to subtract full circle rule, which is 2 pi. But of course, to subtract two values where one of them is a fraction, I need both of them to be fractions with the same denominator. So I can rewrite 2 pi as 2 pi over 1, and then of course I have to multiply by 4 on the top and on the bottom. So I'll get 11 pi over 4 minus 8 pi over 4. That is 3 pi over 4. So these computations tell me that at first I have to do one full revolution, that's 2 pi, which is same as 8 pi over 4, and then I have to travel 3 pi over 4 radians more. So that's where I'm going to stop. And that means that angle that measures 11 pi over 4 radians terminates at the same place where 3 pi over 4 angle terminates. And that means that all their function values are exactly the same. Since we need to find cosine, we just have to look at the x-coordinate of the point that sits on the terminal side of that angle, and that will be our answer. So cosine of 11 pi over 4 is negative radical 2 over 2. And here's our last example. We need to find sine of negative pi over 6. So this time we're given a negative angle. Well, we know that angle is negative. The only thing we have to do is to rotate in clockwise direction. Now, at first, it may feel like counting in radians is a little bit more challenging than counting in degrees. Let me show you a few tricks. First of all, I realized that I need to go same distance as if I had to reach 5 pi over 6. So this distance, but again in clockwise direction. And when I think this way, I don't really need to count because I just rotate that same distance but clockwise. And that's how I find where an angle negative 5 pi over 6 terminates. It terminates here, same place where 7 pi over 6 angle terminates. And of course, I can right away answer the question. So sine is represented by the y-coordinate of the point that sits on the terminal side of that angle. So the answer is negative 1/2. Okay, so the first trick that I wanted to show you is again, first observe how far you need to travel in the positive direction, and then travel same distance but in the clockwise direction. But that's not it. Another interesting observation that we can make if we compare positive and negative angles is that they're always going to be reflected over the x-axis. So if 5 pi over 6 here, then negative 5 pi over 6 will be positioned when I reflect it over the x-axis, on the other side of the x-axis, in other words, right here. And then let's say if 2 pi over 3 is here, then negative 2 pi over 3 will be on the opposite side of the x-axis right here. So same place where we have 4 pi over 3. It's also negative 2 pi over 3 here. And then one more example. Let's say I know that 7 pi over 4 terminates here. Well, that means that negative 7 pi over 4 will terminate over here on the opposite side of the x-axis. So this is how we can quickly find where negative angles expressed in radian measures terminate.